Oh man, you can't come in like that. You're all dirty. Good morning, folks. Well, today is not going to be a construction video. It's going to be an instruction video. For those of you who may want to build something like this or some kind of a motor reversing circuit, they're on the web all over the place, and to be honest with you, I have to look them up to see how the connections go. I won't lie to you. There's a lot I have to look up. But I redrew everything here. But before I do that, I want to show you the circuit. Now, on this, I only needed a few wires, so all these extra wires that I put on here, 16 in total, was not needed. But that's all right, because they're there if I want to make changes. If not, we can eliminate them. But chances are this circuit will be just hooked up the way it is, and it reverses the head just fine. We're running a 6-volt battery for the iMotor. We're running the 12-volt battery, the smaller 12-volt battery, to operate the relays, of which there are 2, one for each relay. Only one coil is energized at any one time. And that's why the single pole double throw switch, or since I've got them and Steve sent them to me because my original circuit was going to be made without relays. In other words, the 10 feet of wire would have to carry, the 18 gauge would have to carry the full current up the remote cord and make the reversing circuit by way of a double pole, double throw switch with just a crisscross pattern, and all you're doing is just reversing the polarity. But we're using the relays, and it's a little more work, actually it's quite a bit more work to get this set up like this, because I have to make it, and I marked off the terminals on the plywood with pencil. You can see that there. So this is just temporary. This is what we call breadboarding, at least my version of breadboarding. So here is how it's going to work. What I got here now, this will be inside the remote. This will be the common negative. With the relay coils, it doesn't matter what polarity you put on them, because it's nothing more than an electromagnet that pulls in. So you can have the polarity reversed, it doesn't matter. If it was a solenoid, yes, because the solenoid is polarity dependent, whether the plunger goes in or whether the plunger goes out. But relays, DC coils, does not matter in this case. So what I'm going to do, and I'm going to have to put this on my little tripod here so I can show you. I've already got the negative lead connected. All I do is take the positive lead and go to relay number 1 or relay number 2. So let me show you how that works right now. First thing, you're not going to see the head move because the camera's aimed down here. This is the negative. Remember now, we're feeding 12 volts. These wires here go directly to the relay 12-volt coils. Okay? Now you'll probably hear the head motor go. Here is one direction, and here's the other direction. You can hear the relays clicking, and each time it clicks, the head moves a little bit more. Alright, now I'm going to show you the actual movement of the head. If the camera don't fall off my little mini tripod here. Alright, here's one direction. Here's the other direction. Alright, now I'll show you how this whole thing works. First of all, we have relay 1, relay 2. And the pins are numbered. Pins are the same on each relay. Okay, I'm not a good artist at all. I just recopied from the side of the relay, and I screwed up, and I put down pins 1 and 8 for the coil here, so I had to scratch it off, and I had to write the coil up here. For simplification, I wanted the coil down here, but you'll understand as I explain. Okay, so pins 2 and 7 are the coil pins on this particular relay. So we're only using half of the relay. So if you split this down, you disregard this part. Although I ran wires out of each socket for the unused part of the relay. Like I say, I did not know what I'm going to be using. So I wanted that option, even though it meant a lot more work putting terminals on it and everything. No biggie. Okay, so what we are using is pins 2 and 7 for each relay, and we're tying one side of the relay coil to the common negative that's going to be in the remote control. Okay? We're just going to double up the conductors of the wires, these wires here that are going to be going up. So I choose to use black for the negative, which is a common thing for auto use. In house electrical, the black would be hot, but in auto wiring and 12-volt systems, black is grounded and red is positive. Well, I don't have red, so I have to use white, but that's all right. Not a big deal, as long as I remember that. So we're paralleling two conductors to carry the current because of all the other things that are in the remote. So I elected to either tie together pins 2 or pin 7 to the common negative. It doesn't matter as long as they're both the same for both relays. Actually, for the coil, like I say, it doesn't matter at all, but you know, you should keep a standard way of doing something. So we're only using the left side of the relay. Pin 1, and I'm sorry about the sloppiness here, I can't draw, and that's why I usually refer to online drawings, even though I didn't write them, and some people get offended by it. So I've had one guy tell me that I used this 3-way switch wiring. Well, not a problem, he just brought it to my attention. It's so much easier because I'm trying to, I can't draw good, you know, so, and I can't see, you know that. So pin 1 is the common, okay? It's the common, and in the normally resting position, in other words, when the coil of the relay is not energized, pin number 1 is connected to pin number 4. In other words, normally closed. When the relay is energized, pin number 1 becomes connected to pin number 3. And I hope you can hear me because it's getting windy out here today, and it's going to rain later. So I'm not doing any work out here. This is just going to show you how I'm doing this. So when the relay is energized, in other words, the coil is energized here with 12 volts, because it's a 12-volt relay, it's switched over to pin number 3. So you have a connection between pin number 1, pin number 3. And when it's not energized, you have a connection between pin number 1 and pin number 4. And basically that's it. It's not all that hard. Okay, now on the circuitry. All right, I redrew this so I can read it. In other words, my size. 12-volt motor reversing circuit using 2 relays. I should have put 2, but obviously in dotted lines here, this represents relay 1, this represents relay 2. This is your motor over here, Now, we're using half of each relay. Relay 1, we're using half of it. We are using pins 1, pins 3, and pins 4 of relay 1. We are using pins 1, pins 3, and pins 4 of relay 2. So in other words, the second half of each relay is not being used. I could choose to use the left half of relay 1 and the right half of relay 2, but there's no point in that. This is for simplification. So the pin numbers are the same, but you got to remember that you're using 2 different relays. Here's your motor. Your motor, there's no plus or minus here because the polarity changes depending on which relay is energized. So the motor is using pin 1 of relay 1. The motor is also using pin 1 of relay 2. Now, in the resting position, which is what this diagram is showing, neither coil is energized, so you would look at this and say, all right, here is pin 1 of the motor. Common sits here, normally closed, goes to pin 4. I don't know if you can see that. I hope you can, because I could be out of focus. I think I'm about 8 or 10 inches away. Now, pin number 4 of the battery. In this case, the battery is 6 volts, although it could be 12, but the head turns too fast. But it will be 12 once I get the motor speed control in the mail. Then that'll be connected here. This will be connected to the output of the speed control. But we're not going to worry about that. We're not going to complicate this whole issue for you folks out there. We're trying to keep it simple. And I'm a simple guy. All right, so your current right now is not, your circuit is not complete because both relays are relaxed. In other words, de-energized. The double pole, double throw switch or single pole double throw switch is in the center position. So neither coil is energized. So your circuit here is pin number 1 travels. You have a continuous circuit to pin number 4, which goes to the battery, pin number 4, or the speed control, whichever you're using. Well, let's just say we're using a battery, 6 volt, which is what I'm using today. All right. On relay number 2, you got the same thing. The relay is relaxed and sit in normally closed position. And you tie in pins 4 of relay 2 to pins 4 of relay 1. So you got a continuous circuit here. So there you go, back to here. All right, now if you look on the positive side, and I don't have polarity marked here because polarity isn't going to matter because it's going to be changed. But all right, let's say that was the negative. Okay, so this would be the positive. Now, if you trace this down, it comes to pin 3 on relay 2, no connection because it's normally the relay's relaxed. It's not being used and not energized, so it's sitting on pin 4. All right, so you trace up this jumper here and you got the same thing here. It's no connection here, so there is no current flow, not energized. Okay, so your current's going to go up here and over here, but this one, if this one gets turned on, then remember this don't move because this is the one that gets energized. Your current's going to flow. The positive's going to come down here, go through here, because this will be connected here now, not here, and it'll turn the motor on, and vice versa. I hope I explained this right. I'm not very good at explaining things. I usually talk too damn much. But basically, you have to think about it. And it took me a little while to trace it out, because I've been away from this stuff for a while, and I've always used motor reversing switches using double pole, double throw. But because I got the relays and it'll be easier on the current drawer, we're doing it this way. Now, down here I got a notation, relay coils not shown. Okay, so obviously you're probably wondering where the relay coils are. That's just going to complicate it. All we're concerned with is the contacts. We're not concerned with the relay coils. If you know how a relay works, you don't need to show the coil other than in the original diagram as to what pins they go to. So, and also there's a notation down here, only one relay is energized at any one time. Okay, so that's important. So what would happen here is we'd have 12 volts coming in. Now, I just tied these together. It doesn't matter whether these are negative or positive because they're energized only by energizing a coil. So in the remote control, one side of the coils will be grounded, and they could be grounded here at common negative, in which case this would be positive, and a double pole double throw switch could throw the positive on this leg and reverse the motor, or when you flip the switch the other way, throw it on this leg. Either way, it's going to work. But for breadboarding show and tell, it's easier for me to do this. I mean, it all works the same anyways. So I got all these wires here that I don't really need. So there are some that are jumpered over, like pin 3 is tied together to pin 3 from one relay to the other, and pin 4 from one relay is tied to pin 4 of the other relay. So I can do that at the board and eliminate unnecessary wires, and that's exactly what I am going to do. As a matter of fact, I am going to do that, but I'll do it off camera. But I wanted to show you basically how a motor reversing circuit is drawn and used for 12 volt or 6 volt, doesn't matter what the voltage is, as long as the coils in the relay match up with whatever supply voltage you're supplying them with. If you're using 24 volt coils, you'd have to use two 12 volt batteries in series, or whatever the case is. Now the motor, the head motor is being run on 6 volts, or it'll be run on 12 volts once I get the speed controller in. So one battery can take care of it, so I don't need to worry about having a 6 volt battery here, because if the speed controller does what I think it's going to do, this input here will be connected to the speed controller, and that'll handle the speed of this thing, and the reversing circuit will work the same. It doesn't matter what it gets here. So for all intents and purposes, it doesn't matter what voltage you put in here. I mean, if you can put a 1.5 volt dry cell here, and you can have a 1.5 volt toy motor here, it'll still work the same. It doesn't matter. What does matter is your relay coils. They have to have the proper voltage to run. So that's the only thing, and of course naturally you got to have relays that'll handle the current. These particular relays here are good for 10 amps. We're not drawing 10 amps. I've measured the current of this motor, and it's under 10 amps. You know, when I held it back, it's probably around 6 amps, as I recall. I made a video on it, and I didn't actually show you, but I told you about it. Try to hold it down, simulating a real heavy load on the Oracle neck. Alright, I just want to show you, I simplified the things, and I pulled out the wires that I did not need, and I can use these because they got the clips on them already. So we're not using all the wires. We're not using pin 6, pin 5, or pin 8. 6, 5, and 8 we're not using on either relay. So we eliminated some wires. So this is how it is. And now when I mount that, I'll make sure that it's mounted on that board, that the screw don't go hitting these wires here. Sammy is checking out my work here. He's checking out my tool inventory here. Is that what you're doing, Sammy? Huh? That's it, folks. I hope you enjoyed the long-winded video, and I hope it helped out some of you guys out there that may want to wire stuff up like this. I appreciate you watching. You have a good day.